All right, good day, guys. Got another video for you. This is a new formula for finding the area of a triangle using trigonometry. Now I'm going to do it kind of reverse of what I did in class. In class, we developed the formula. I showed you an example, and then we used the formula. Here, I'm just going to show you how to use the formula, and then later in the video, I'm going to explain where it comes from, because I think where it comes from is a little trickier than seeing how it's used. So let's see how this works. So if you have any triangle, it does not have to be a right triangle whatsoever, and you have two sides, see how that side of 18 and that side of 20, how they connect? And when they connect, this is called the included angle. This angle is 39 degrees. I can use these three pieces of information to find the area of this triangle. And the formula works like this. The area is equal to 1/2 of both of those sides multiplied together times the sine of the angle in between them. That will get you the area of that triangle. So in this case, the area would be 1/2 times 20 times 18 times the sine of 39. So the area of this triangle is 113.28 square units. It's not a bad formula to use. It's pretty straightforward when you see it in use. Now, when you develop it, it's a different thing, but I wanted you to see it in use first. Now I'm going to show you how you usually see it in a book or online. You usually see this. So really what it means, I'm using three letters A, B, and C. The A and B are the two sides, and the C is the angle that's right between them. So you're looking for two sides with the angle right between them. So let's do another example. I've got these two sides of 17 and 10, and I have the angle in between them. So my area formula will be written as 1/2 the two sides. And it doesn't matter which side is first. Remember, multiplication is commutative. It doesn't matter which one goes first. So 10 times 17 times the sine of 80. That's it, just like that. And then use your calculator to figure out the answer. So 10 times 17 times the sine of 80. So this area is 83.71 square units. All right. All right, another example, because it works with obtuse angles as well. As long as the two sides, the 14 and the 15.2, as long as that angle is created from the connection of those two sides, this formula will work. So the area is 1/2 of the two sides times the sine of 132 degrees. So your calculator will handle that, so it's not a problem. 1/2 times 14 times 15.2 times the sine of 132. So that area is going to equal 79.07 square units. It's very straightforward how you use it. So on this page, there are 4 triangles. 2 of them we can use the formula for right now. 2 of them we cannot. Now I said right now because we're going to be learning a technique a little bit later where we can actually find sides that we don't know. But for now, for what I showed you, which 2 can you use the formula for? Right now I'm going to highlight the sides that we have. So in this triangle, I've got these 2 sides. Do I have the angle in between them? I do. This one would work. For this triangle, I've got those 2 sides, and where they're connected, do I know that angle? I do not. For this triangle, I have these 2 sides, and I need the angle that's between them. It's not there. So can I do this problem? Well, I can, because I know these 2 angles are 30 and 20, so I can calculate that one. So I can use it on this one. And for this one over here, I have TS and SR. Do I have the angle that is created from those two line segments? I do not. So yes, I can use it. No, I cannot. Yes, I can. I just have to figure out that angle. 20 plus 30 is 50, and 180 minus 50 is 130. So I know that angle is 130, so I can use it. And this is a no. I have these two line segments. I do not have the angle in between them. So if you're okay with that, awesome. You can turn the video off now and get to work. If you'd like to know why the formula works, hang on, because I'm going to show you right now. So this is the first example that we did. The answer is down here in the corner. What I'm going to do is use our old area formula, the one that we know, 1/2 base times height, and see if I can get this answer. Now, a little note of warning. In this formula, h means height, and we're doing trig now, where h means hypotenuse, so just be careful. This is just h means height. What I'm going to do is I'm going to draw an altitude. So I'm going to draw a line straight down. Now, because it's an altitude, I'm going to make it a dotted line so we can tell the difference between them. So that's the altitude. That's the height of that triangle. And when it's a height, it makes a right angle with the ground. With the base, shouldn't say the ground. Remember, the base and the height have to make a right angle. So I know my base is going to be 20 in this particular example. I still have to figure out the height. Now I'm not going to call it h because I don't want to get it mixed up with the hypotenuse. I'm just going to call it x. Can we figure out x using our trig ratios? I'm going to highlight this triangle that we've created. So in our trig ratios, we can use right triangles. So I've got a right triangle right here. Can I find that value of x? Let's set up the trigonometric expression to find that value of x. All right, I'm going to use this angle. I've got the opposite and the hypotenuse. So that is going to be the sine of 39 degrees equals the opposite divided by the hypotenuse. If I calculate that, I'm going to multiply both sides by 18. Now, instead of just finding an answer and multiplying it, I'm going to write the whole thing out. What does h actually equal? It equals 18 times the sine of 39. So do you see what I've done here? I have both sides, the 18 and the 20, and the angle that is between them. It works this way every time. For a more formal proof, I could just put letters here instead of numbers and come up with the same idea. But this is a demonstration of why this works. And when we find that answer, of course, we're going to get 113.28. So I hope this helped out. If you have any questions, as always, let me know. Good luck, and I will see you in class. Bye.